Hello again. In this video, we're going to look at the equations and graphs of polynomial functions. Specifically, we'll identify the zeros, degree, and end behavior of the graphs and equations of polynomials. Remember, a zero is the same thing as a solution, a root, or an x-intercept. It's the place where a graph crosses the x-axis. Let's take a look at question 1 here. We're given an equation, x cubed minus 4x. This f of x is just a fancy way of writing y. It's called function notation. In order to determine where the zeros are, or the places where the graph crosses the x-axis, we're going to need to graph it. On our graphing calculator, we'll type in the equation, x to the power of 3 minus 4x, and hit graph. We can see where the zeros occur. Looks like it occurs here at -2, 0, and 2. Writing this as an ordered pair, it'd be -2, 0, 0, 0, and 2, 0. Let's find the example that's not one of those three. Here we have positive 2, 0. That's this first one over here. We have -2, 0. That's the one on the far left. And we have 0, 0. So the one that's not a 0, that'd be 0, -2. That'd be down here 2 units on the y-axis. It's not an x-intercept at all. Next, it asks us, as x goes toward positive infinity, what happens to f of x? In other words, as we keep getting larger and larger values of x, does the y value become larger, positive infinity, or smaller, negative infinity? Well, let's take a look. As we start at 0 and keep increasing the value of x, the value of y keeps going up, more and more positive. So that means as x goes toward positive infinity, y, or f of x, also goes to positive infinity. Going the other way, as we go in the x direction toward negative infinity, our graph also goes down in the y direction. So as x goes toward negative infinity, f of x also goes toward negative infinity. Finally, we need to look at the degree. Remember, the degree is the highest exponent on a variable. Looking at our equation, we have x to the power of 3 and x to the power of 1. The highest exponent is the degree, so the degree of this function is 3. Let's hit check just to make sure we're right. Oh, good. Got it. So that's an example of how to solve for an equation. Graph the function, identify where the zeros are. We'll select the one that's not a 0. In this case, that was something that had 0, -2. That was on the y-axis. We'll identify the end behavior as x goes toward positive and negative infinity, and then we'll find the degree by looking at the highest variable on an exponent. The other type of question you'll face in this assignment is if you're given a graph. We won't need the graphing calculator for this one. So it says use the graph to answer the following questions. Well, we already have the graph, so now we can identify the zeros. It looks like this graph has 4 zeros. Right in between -4 and -2, that must be -3. Right over here between -2 and the origin, so that must be -1 at 2. And halfway between 2 and 4, that'd be 3. So this graph has zeros at -3, -1, 2, and 3. And all of those need to be the x-coordinate. So the y-coordinate for each of those points must be 0. So -3, 0, -1, 0, 2, 0, and 3, 0. So 3, 0, that's the one on the far left. -3, that'd be right here. +2, it's this one over here. -1, and the last one is the one that doesn't belong, -2, 0. There's no place where the graph crosses the x-axis at -2. So -2, 0 is not a 0 of this graph. Next, we look at the behavior of the graph as x goes toward positive infinity and negative infinity. Mind the negative sign right here after right before the infinity sign. So as x goes toward positive infinity, as x gets bigger and bigger, what's happening to our y? Well, it looks like this graph is going straight up. So that'd be toward positive infinity. As we go in the other direction, the graph is still going up. The further we go to the left, the further the graph goes up. So that means f of x must be going to positive infinity as x gets more and more negative. Last, we need to determine the degree. We can't really see what variables are on this exponent. We could do a quick check using our calculator. If we were to graph y equals x squared, we'd see that there's one curve. If we graph y equals x cubed, we'd see that there's kind of one curve here on the left and another curve over here. Looks like there's two curves. As we keep increasing the degree, we add an additional curve. The simplest one to see is x squared. When the degree is 2, there's one curve. Well, this graph has one curve, two curves, three curves. So one curve would be degree 2. An extra curve, that'd be degree 4. This one here would make it degree 2 for one curve, degree 3 for the next curve, degree 4 for this third curve. So this function could be degree 4. We don't know for sure because we can't see an equation. There could be some other curves or some hidden curves in here, but it looks like since there are 3 curves, there must be, the degree of this function could be 4. Let's hit check and see if we're right. Got it.